Okay, now we're entering the module for creating and modifying movements. But first, I would like to dive into some thoughts here and understand some key points of movements and how does the movement system works in robots in general. Okay, here in KUKA, you notice that we have some different instructions for creating movements, and there are differences between them. But you notice that all of them has a similar structure. So I think of that the first thing that we should ask is and understand is how does the robot memorize the current position or the position of the target? Basically, the robot will have the respective position of the tool in the space regarding to its coordinates and regarding to the position regarding the base and the axis and everything that defines a specific point in space. And we can save this in a keyword. We can call this point in space like POS. And the robot will understand that every time we call POS, we are referring to a specific place in the space that have specific coordinates that the robot saved once. The other thing to ask is how this movement should happen. Should we allow a point-to-point movement or a joint movement? Should we need a specific linear movement? Do we need to create a circular movement? So there are instruction options for all this type of movements. Basically, we have PTP, which is similar to move joint in ABB. We have Lin, which is equivalent to move L in the ABB robots, for example. And we have Circ, which is equivalent to move C in ABB. Also, it's worth noting there's another movement here in KUKA. It's called spline. We'll talk about that soon, and we'll take a look what spline actually is. But we also have to know one thing: this movement, what speed the robot should maintain during this movement. So this is also something that we need to configure. The robot needs to execute the movement in a specified way. We need to define this with VL for velocity or ACC for acceleration and define those parameters for the movement. So those are the things we need to keep in mind. Other thing that we need to keep in mind is should the robot stop exactly at each point? Or it can, for example, if moving from point 1 to point 2 and then point 3, not necessarily go exactly into point 2, but create a small diversion in the movement. So should a robot stop at each point? It depends on the application, of course. It depends if you have collision zones. It depends if you have a robot in a tough position where it would be difficult to create a linear movement. So it depends on the process. But this is also parameterized using the cont parameter here in KUKA. So those are things we need to ask, okay? What type of movement do we need? Where is this point and how can we define this point inside the KUKA robot? The type of movement will define the instruction. We also need to know if the robot should stop at each point exactly, or it can be small diversions. And we also need to know the speed of this movement that we need to understand. So those are the primary principles for us to define a movement. And all of these need to be taught by the developer of the application. So each case is a case. Here in ABB we have the count for those movements that we don't need to stop in each point. This is similar to zone in ABB or PL in Model Man robots and Yoskawa robots. But here in KUKA we see it as count. Okay, count stands for continuous. So this is something that we need to do. One thing to keep in mind is that the robot, let's imagine that you have 3 points again, and between point 2 to point 3 there's a risk of collision. Maybe another robot moving, maybe a part of the device. And the question is, does the robot detect this? And the answer is no. So The movements you are creating, you need to define the specific zones to avoid situations like collision. So this is the responsibility of the programmer. Okay, the robot detecting obstacles does not exist in most models in the industry that are used widely. So, but there are parameters for that you can configure for collision detection and calibration. You can define a sensitivity level, for example, for a collision detection if enabled, and the robot will detect this collision and stop and generate a collision alarm. This is a feature we have to define the sensitivity, and it's very important to know that this is not a guarantee that there will be a collision in your process. Maybe the time to stop after the detection of the collision isn't enough. So of course it's really fast, but it's not enough to induce harm. So to recap, what we've considered so far, basically we have some movements we can create inside KUKA, such as PTP, equivalent to move joint. We also have lin, which is a linear movement, circ, which is a circular movement, and we also have spline, which is used for creating trajectories with curves in a more precise way, or we can create more complex movements with this in a more optimized way, resulting in smoother movements of the robot. But you can achieve these similar results using just linear and circular, but here in KUKA we have this spline, which is also great. So spline has obviously its advantages, it's something specific, but essentially with this three type of movements we work on are PTP, lin, and circ. Obviously I don't have a manipulator here, so I cannot demonstrate the robot moving, but we can base our understanding on the current position as we've seen earlier. That's it for now. We'll see how it works in the next lessons.